Hi guys, so today we're going to rewrite this rectangular equation in parametric form. So keep in mind that the first thing we're going to do is recognize what type of equation we have here, which is the equation of a circle. So if I write underneath the standard form of the equation of a circle, we can identify the values that we have, which include h, k, the center of the circle, and the radius. So h would be -2 because remember it's subtraction and the 2 is being added. K would be 1. And then sidebar, we're going to solve for the radius of the circle, setting r squared equal to 4. Get rid of the square by square rooting, both sides. And the radius, while solving it mathematically, would be positive and -2. Keep in mind the radius is a distance, so we're only using +2 as the answer. Now, we're identifying h, k, and r because to write it as parametric equations in terms of x and y, there's actually already a formula. So for x, we would write h plus r cosine of theta. And for y, we would write k plus r sine of theta. So since we already have h, k, and r, substituting those values in, -2 plus 2 cosine of theta would give me the parametric equation for x, and then 1 plus 2 sine of theta for y. Okay, so we're starting off hopefully nicely because the next problem, it's going to be a little longer. It is a word problem. Keep in mind that I'm just helping you with this word problem. I did not make it up, but we do have some values to identify like before where we identified h, k, and r first. So our angle would be 43 degrees. We have an initial height of it being 1.5 feet off the ground. So we're going to note the initial height as h sub 0 and its initial velocity v sub 0 would be 79 feet per second. Make sure that the units match. So everything's in feet for distance and for time should be in seconds. And we're trying to calculate how far the ball lands in feet when hitting the ground. So the first thing we're going to do, since the ball landing when hitting the ground would be a horizontal component, is that we're going to find the vertical and horizontal component of our vector, the velocity. So we're going to start that off with v sub x equals v sub 0 times cosine of theta. And then v sub y would equal v sub 0 times the sine of theta. So since we have these values, we're going to substitute the values in, but make sure when you're calculating that your calculator is set to degrees because the angle is in degrees rather than radians. So 79 cosine of 43 degrees should result in 57.78 feet per second. Because we're dealing with velocity, it's always in distance over time, like miles per hour, in this case, feet per second. Same thing with v sub y, 79 times sine of 43 degrees. Calculating that would give us 53.88 feet per second. Now, why are we calculating this? So we're actually bringing it back to an algebra formula that we had back in Algebra 1, distance equals rate times time. Distance is nothing more than what we're solving today, the distance of how far away the ball lands. The rate is the average rate of change, which is just the speed, in this case our velocity, but with the horizontal component because it's when it hits the ground, times time. So just kind of to prove what we're doing here, velocity is in feet per second, time is in seconds, and notice that if we multiply them, seconds will divide out, leaving us with just feet, which measures the distance. So we have v sub x, but we're missing time. Time is nothing more than a realistic way of solving for x. So we need to find our x value. Keep in mind, I did not create this problem. I am just showing you how to solve it. There is a physics formula, half of acceleration times time squared plus the velocity times time plus the initial height. If you take physics, you're familiar with this. Now, since the object is free falling, the acceleration would be gravity. Gravity is a constant. Since we're dealing with feet and seconds, it would be negative 32 feet per second squared. So nothing to solve there, but the first term would tell us it would be negative 16 t squared. We already have v sub y from our calculations of the vertical component of the velocity, and the initial height was given to us in this problem. So keep in mind, we're solving for when the ball hits the ground. So y, the height, would be 0. Now, we can't factor this to solve this quadratic equation, so we have the quadratic formula to fall back on when something can't be factored. Quadratic formula, bringing back algebra 2. A is the coefficient of t squared, which was negative 16. B would be 53.88, and C is always the constant, the number by itself, which is 1.5. So we're going to plug these values in to the quadratic formula, and that'll help us solve for, in this case, the time. So negative b would give us negative 53.88 plus or minus the square root of b squared, which is 53.88 squared, minus, and then I like to multiply 4 times a times c, meaning I bring the minus over, and then on the side now in the calculator, I type in 4 times a, which is negative 16, times c, which is 1.5, and that gives me negative 96. I'll worry about the double negative later, just trying to get the values right first. And then over 2a would be over 2 times negative 16, which is negative 32. So bringing everything down, I'm just going to work with what's in the square root. And 53.88 squared minus negative 96, which technically be plus 96, would give me the square root of 29.99 over negative 32. So I'm actually going to have two answers here. The first one would be negative 53.88 plus the square root of 29.99. Always press equals after the numerator and divide it by negative 32. So plugging that in, I would get negative 0.028, and then the other one would be negative 53.88 minus the square root of 29.99, press equals, and then divide by negative 32, and that would be 3.395. Keep in mind that I'm not really solving for t, I'm solving for x here. I'm solving for t, which is time, because we're taking a more realistic approach with this word problem. Time can't be negative, so we're going to take this positive time. And remember, this is not the answer. We're going to go back and take this time with us, 3.395, and we're going to plug it into that formula we discussed, that we were missing time. We already have v sub x, so we're bringing that down again, 57.78, and our newly found value of time. And we're going to multiply the two to find how far the ball lands in feet when hitting the ground. So that would be 196.16, and remember that the seconds canceled out, we're left with feet, which is in distance. All right, guys, hope this helps.